Tell me to correct it at the end of the class. Tell me which one is not you. Okay, let us look at this question. We were solving some questions in the previous class. Let us have a look at this question. This is again from, I think, previous term. It says that using the data on heights of female and male students, here are female students, here are male students, this is the scale. We construct the following comparative box plots. There is the comparative box plot. Which one of the following is true about the comparative box plot? Now, this is a choice-based question. So I will show you why A is correct, and I will also show you why B, C, D, and E are not correct. According to this box plot, what is the median male age? Roughly speaking, around 68. What is the median female age? Roughly speaking, 63 or maybe 64. The question is about Q1. What is the Q1 for females? Let's guess all of them. Now we can see that the male age, what is the IQR for male age? This much. For females, this much. So IQR for the male age is higher than the IQR for female. That's why option A is correct. Why B is not correct? Female students, they have a higher median. Do they have a higher median? No, this is 63, this is 68 something. So males, they have a higher median. Both genders, they have the same range. What is the range? You cannot see the range from the box plot. The version of the box plot that we are giving you in exam, it is based on, this one is Q3 plus 1.5 times IQR. This one is Q1 minus 1.5 IQR. So box plot is not giving you any range. You cannot conclude anything from the box plot related to the range. Yes. Which line? Black line in the middle is median. What? No. For the box plot, it's mean. If median, if you have to put the mean, some of the softwares, they give you an option of something like they put an X at the mean. But in general, the line is the median. This is Q1, this is Q2, this is Q3. Why option D is incorrect? Female students, they have a higher Q1. What is Q1 for females? 62 something. And what is Q1 for males? Sorry, I put the other way around. It is around 66, which is wrong. What is Q3 is same for both genders. Is it same? No. Mobiles, put the mobile in the pocket. All the mobiles in the pocket, yes.
Could we estimate the range?
No, you cannot.
Why?
What if there is an outlier here? One of the male is here. There is no way to. Next question says, this is, I think, previous term, 2, 3, 3. You are told that the minimum, first, second, third quartile, and maximum. So we are giving you X1. We are giving you Q1, Q2, Q3, and Xn. Usually in statistics, this notation is for the first value, and this notation is for the first arranged value, which is minimum. When I put a bracket, that means I arranged the data already. Without bracket is unarranged data, but not from exam point of view. Maybe from my notes point of view, you will see bracket means arranged. For some blah, blah, blah. The values are given here. This is minimum. 251 is Q1. 260 is median. 275 is Q3. And 295 is the maximum. The data contains outlier because the minimum distance is less than the limit for the outlier. So we need to first compute the limit for the outliers. The limits are what? First, I compute IQR. That will be 275. Someone with a calculator, please help me speed up this one. 275 minus 251. This will be 24. 1.5 times 24 will be 36. So the lower limit will be 251 minus 1.5 times 24. 251 minus 36. 251 minus 6 is 45. 35, 25, 15. 215. Tell me if I'm wrong. 275 plus 1.5 times 24. 275 plus 36. 200, 300, 310, 311. Now, is the lower, is this 295 highest value above the upper whisker? No, it is not. Is 210 below the lower whisker?
Yes.
So there is an outlier, which is from the minimum side, there is an outlier. So the data contains at least one outlier. Maybe there are more of them. Contains outliers because the minimum distance is less than the limit. A is true. Why B is not true? The data contains outliers because the maximum distance is more than outlier. No, maximum is 295. It is not more than the upper limit. Why C is not the right whisker is longer than the left whisker? No, the whiskers are equal distance. The interquartile range is approximately 10. Is it 10? 24. The data are symmetric. Usually we can see the symmetry of the data by looking at the distance between Q1, Q2 and Q2, Q3. If the box plot is something like this, this is positively skewed. If the data is like this, box plot, I mean, negatively skewed. So you can check the distance. I think the distances are what? Let's go back to the distance between Q1 and Q2 is 9. Can you see? And the distance between Q2, Q3 is 50. This seems like skewed to the right, not symmetric. Slightly skewed to the right. Question 13 from 233. Yes. Yes. Same distance. Or the part C? C. This one? This is 251 plus this is same, 1.5, 36.
It's always
Yeah. From Q1 and Q3, they are equally distant, but not necessarily from median. Median can be different. Yes.
So, this one, how is it?
Which one?
Because you said it's the what's called how.
If you draw the box plot here, let me have a scale. Suppose this one is 200 and this one is 300. This will be 250. This will be 225. This will be 275. Where will I get the Q1? 251. It will be somewhere here. Correct? 260. It will be somewhere here. And then 275. It will be somewhere here. And my box will be something like this one. Right? So which side is longer? So it seems like a little skewed to the right, not symmetric. A little skewed to the right. Like it is more like this box plot. Right? Whiskers are equally distant. Here, 36 here and 36 here. This is what somebody asked from here. Whiskers 36 on the right, 36 on the left. Always? Yeah. Whisker 1.5 IQR on the right, 1.5 IQR on the left. It's not, I would not say it's always true. It's an estimation. It might be wrong. The actual data might be positively skewed and box plot is showing you negatively skewed. But it's an estimation. Everything is subject to error. Right? Shape of the, yes, based on the position of the median. If the position of the median is in the middle of Q1 and Q3, your guess is symmetric. If it is more to the left, then right skewed. More to the right, left skewed. Question 13, the following data on the motor fuel octane rating of several blends of gasoline, it has this. Luckily for you, they gave you the arranged data already. I can see the data is already arranged. They ask you to find the 90th percentile. The easiest way, put the formula sheet in front of you. Rank of 90th percentile is 90 times n plus 1 by 100, which is your n is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 90 times 21 calculators. 1 point? 18.9? 18.9. So the P90 is 18th value plus the decimal part, which is 0.9 times the difference of 19th value and 18th value. What is 18th value in your data? Here are the two values, right? 18th and 19th. So you have 94 plus 0.9 times 96 minus 94, which is 2. 94 plus 0.9 times 2. What is 0.9 times 2? Not 1.8. Is it? Yes, 1.8. So it will be 95.8 here. Okay. A sample of 8 measurements were made on the inside diameter of 4. What? The data is 8 values. If A is the estimator for the population mean, A is the X bar, compute it yourself. B is the estimator for the population standard deviation. B is S. I think simple computation. You have to find X bar minus S. Okay, so find mean, find standard deviation, and I think it will correspond to one of these options. I don't see any complication in this question. Simple, but there is a big majority of the students that will make mistake in this one while using the calculator. So make sure you are very comfortable with whatever calculator you are using in the example. Here again, this question is also long because we did not give you summation x and summation x square. The easiest way to go along this question is to find sum of x and find sum of x square right in the beginning, and then use it for both formulas of S and X bar. Now we move on towards some of the questions on the exercises I recommended to discuss in the class for conceptual point of view. Some of the questions which are more towards the practice, I gave it to you to solve them. The first conceptual question, will the sample mean always correspond to one of the observation in the data? Not necessarily. Why? Because it's the average. And average, not always, rarely it corresponds to one of the data points. In general, it doesn't correspond to one of the data points. Will exactly half of the observation be below the mean? Will exactly half observations be below the mean? Suppose this data, 1, 2, 3, 107. What is the mean of this data? Calculators. 1 plus 2 plus 3, 6, 107 plus 6, 113 divided by 4. 20, 28.25. How many values are below? 3. How many values are above? 1. Mean is a magnitude-based measure. It's not a location-based measure. So location statements are not valid for the mean. This is location-based statement. Half observations below. For median, this statement is true. Median, yes. For median, it is true. It is true. For median, it is true. Will the sample mean always be most frequent value in the data? That's mod. Most frequent value in the data will be mod. And for the data sets which are symmetric, usually their mean and mod are equal, usually. So for the symmetric data, maybe it is true, but in general, this is not true. In general, this is true for sample mod. Yes. Here, take 3 values. Now find the mean.
No. What's the mean? No.
Median, yes. Median will be 2. Half value is 2, one value is below and one value is above, and we consider the 2 itself to be half above and half below because it's equal. So 1.5 value is above, 1.5 value is below.
Plus.
Yes. For 4 values, 2 will be below, 2 will be above. The statement will always be true for median. Yes.
So it's just for the.
No. Yes, yes. For population, not for sample. For population, yes. What is the difference between population and sample? Sample is part of the population. Why don't we study the whole population? Why do we take sample? Money. Cost. Will the sample mean cost or sometimes availability? The whole population sometimes is not available. Suppose I want to draw some conclusions about all STAT 319 students. What are all STAT 319 students? All the current students, all the past students, all the future students of 319. So the past are not available, the future are not available. So sometimes availability constraint. For any set of data, is it possible for the sample standard deviation to be less than sample mean? Can standard deviation be less than mean? What is standard deviation? It tells you about the variation in the data. What is sample mean? It's the center of the data. The sample mean has nothing to do with sample standard deviation, or sample standard deviation has nothing to do with sample mean. Let me give you an example. 1, 10, and 19. This is the data. What is the mean? Mean is 10. What is the standard deviation? Does anyone have a calculator that computes standard deviation directly? You give 3 values. Don't bring it to the exam. One, 10, and 19. Font size is okay or not? Now, okay, so the mean is 10 and the standard deviation is instead of this, let me call it 100 and 199. The mean is, again, standard deviation is, let me make it minus 20, 0, 20. What is the mean? 0. What is the standard deviation? 20. Standard deviation is more than mean, right? Then I have another data set, 100, 120, 140. What will be the mean? What will be the standard deviation? Do you observe that the standard deviation is same? It's just a coincidence or something special behind it? What is that something special? Standard deviation measures the distance of each value from the mean. And if you observe, this data is nothing but this data plus something, plus 120, right?
Yes.
So adding any constant to the data doesn't change the standard deviation. If I have a data and throughout the data, if I add something, it doesn't change the standard deviation, but it does change the mean, right? Mean was 0, it changed to. But from the question point of view, standard deviation has nothing to do with the mean. You can have a data where mean is bigger than standard deviation. You can have a data where standard deviation is bigger than mean. So for any set of data values, is it possible that standard deviation is smaller than mean? Yes, it is possible. If so, give an example. Give an example where standard deviation is smaller than mean. Give example like this one, 9.9, 10, 10.1, very small standard deviation. Put the values very, very close to mean. In that case, your standard deviation will be small. Can the standard deviation be 0? A 1.
All the data. 10.
For this data, the standard deviation will be 0. Suppose that you add 5 to all the observations in a sample. What happens to the mean? What happens to the standard deviation? Let me take the sample. You have a sample. Let me go to the Excel. Let me keep the mean to be 10 and standard deviation to be 3. 2. Okay, let me say I have these 10 values. Let me fix them. I have these 10 values. For these 10 values, I find the mean. And the mean comes out to be 10.1. Good. And I find the standard deviation. And the standard deviation comes out to be 2.02 something. Let me round it to 4, exam point of view. Okay, now what I do is for the whole data, I will add, let's say 20 to each value. So it will be 20 plus the previous data. To each value in the data, I added 20. What will happen to the mean?
Increase.
Mean will increase by how much?
20.
By 20. If I added 20, mean will be added to the 20. If I multiply 20, mean will be multiplied by the 20. I will show you that. So when I take the mean of this one, this is simply, why did this change? 10.1. This should be 20 plus 1, 30. Why is it not average of A1 to A10? B2 to B10, 27, 29. Ah. 30.1. Simply, the new mean is the old mean plus 20. What will happen to the standard deviation?
No change.
No change. You see, it stayed the same. Mean will change by adding into 20. And I will write the expression for you here, and I will also write it in the OneNote later. Everywhere. It will increase by 20. So the mean of x plus 20 will be the mean of x plus 20. Okay? The standard deviation of x plus 20 will be simply the standard deviation of x. It will not change. The mean of x multiplied by 20 will be the mean of x multiplied by 20. The standard deviation of x multiplied by 20 will be standard deviation of x multiplied by 20. Let me write one more thing here. The variance of x plus 20 will be simply the variance of x. And the variance of x multiplied by 20 will be the variance of x multiplied by 20 squared. Now keep that in your mind and let's multiply 20 here. Instead of 20 will be a huge number, I will multiply it by 2. Multiply each value by 2. What happened to the mean? Mean was 10.1. When I multiplied by 2, mean became 20.2, 2 times the mean. What happened to the standard deviation? 2 times. What will happen to the variance? 2 square, which is 4 times the old variance. The old variance is 4.1. And the new variance is 4 times 4.1, which is, if I multiply it by 3, what will happen? Mean will be 3 times the old mean. Standard deviation will be 3 times the old standard deviation. Variance will be 9 times the old variance. So that thing will come into the picture. That relationship will come into the picture. Let's move on. Any questions? Okay, let us go to this question. This question says that in April, the specific date, the U.S. Air Force, it flew 1,255 combat sorties for a total of 6,978 hours. In April 22, this is a single day. In that day, U.S. Air Force, they flew the pilots, they flew how many combats? 1,255 combats total for a total of how much time? This much time. What is the mean duration of the flights? You have the sum, and you have the number. What will be the mean? Mean will be 6,978, the total flight time divided by 5.56. So on average, each plane flew for how many hours? 5.56 hours. Now, why I brought this question to the class is the last line. Is this sample mean? Why did I write here mean? Why I didn't write X bar? Is the sample mean or population mean? It's a population mean. Why? Because it is talking about the average of all the flights on that day. If you select some of those flights and then take the mean of those some flights, that will be sample. So why is this parameter? What is a parameter? Parameter is any quantity which is computed from the population. Like the mean of population is a parameter. Standard deviation of population is a parameter. Median of a population is parameter. The corresponding quantity computed from the sample is called statistic or estimator. Sample mean is a statistic. Sample standard deviation is a statistic, and so on. So this guy here is population mean, which is denoted usually by mu. It is not X bar. It is mean, mu. X bar is the notation for the sample mean, and mu is the notation for population mean. One of the mistakes you might make is we might give you one of the options as 40 times the variance of X. 20 square is not 40. Read the yellow highlighted part. It says that on April 22, 1991, Air Force pilot flew a total of 1,255 combat stories for a total of this many hours. So this is about all the flights, not some flights. So when you're talking about the totality, all of the flights, that's population. When will the median of a sample be equal to the mean? Not only normal. Symmetric. Which includes normal. When will the median of the sample be equal to mod? Again, symmetric. For example, this one, median is here, mod is here, mean is here, all three of them there. For a symmetric distribution, the three of them usually equal unless you have a bimodal distribution or this kind of distribution. Mean is in the middle, median is in the middle, mod is in the middle, all of them in the middle. Yes. Bimodal is symmetric, yes. But in that case, mod will not be median. Yes. When will the median be? No, not this one, not this one. Yes. For this one. For this one, symmetric, but unimodal. Yes. The median will be equal to the mod when the sample is symmetric, but unimodal, single model. It has one mod. Not like this. This is symmetric, but bimodal, two mods. Two mods. And there can be more than two mods. Yes. It's symmetric. I did not say skewed. It is symmetric. Draw a line in the middle and see is the left side of the line mirror image of the right side? If yes, symmetric. Yes. Here on one note, whatever I'm writing is there. Yes. Can you see it? I think it will be updated immediately within a few seconds. 90. I was more interested in the last part of this question, C, but let me look at A, B, and C all together. A sample of 6 resistors, it gave you the following values. Now, one of the deceiving things here is they use notation x1, x2. These are values actually. These are not means. These are not ordered values. These are values, 6 values, 45, 38, 49, and so on. Compute the sample variance and sample standard deviation. I don't think there is any complication, but I will show you what am I aiming for in this question in part C. Let me enter the data. 45, 38, 49, 45, 38, 49, 43, 35. I wrote 28. I should write 38. Then it says 43, 35, 43, 43, 35, 43. Here is your data. For this data, from exam point of view, first you will find 253, which is the sum of all the values. Then you will find square all the values. The sum of square summation x square will be 10793. You will go step by step. In exam, you don't have the Excel. Then to find the mean, you will do what? Equal sum. Also, you will have n somewhere. Not length. The n for this data is 6. So your mean is summation x divided by 6. Round it to, in exam, round it to 4 decimal points. So you will report the mean to be 42.1667. The standard deviation, before standard deviation, you must find variance. The variance will be, let's go back to the formula. It is summation x square, which is here 107 something, minus n times 6 times x bar square, x bar multiplied by x bar divided by According to the formula, n minus 1, n minus 1. Here is your variance, round it to 4. $24.9633. If I find the variance directly, Excel will give me, because of rounding maybe a small difference, 24.9667. So the difference is at the third and fourth decimal because of my rounding, but no issues. Then I will find the standard deviation. Square root of this guy, rounded to 4 decimals. 4.9963 is the standard deviation. So my part 1 is answered. It says that compute the sample variance and standard deviation. The variance is 24.9633. Standard deviation is 4 point something. Yes. Better not to round. Better round only the final answers. Better round only the final answer. Don't round at every step. Round only the final answers. The interesting part here that you can solve even without any computation. Subtract 35 from each of the original observations. So x minus 35. Subtract 35 from each value. Then compute the variance and standard deviation again. What will happen? Nothing will happen. You will have the same standard deviation, same variance because of the relationship that we have. That's a mathematical relationship. You can prove it even. Not included in your course, but you can prove that. So if I subtract 35 from each observation, 38 minus 35, and then I find everything. Again, I do that. What is this one? So I see the standard deviation and the variance, they are unchanged. Why there is a little change here? Because of rounding. Where did the rounding come into the picture? Where I'm using the mean. Summation x square and blah, blah, because of the rounding. But up to fourth decimal, if there is difference, no issues. Then what does part C say? If the resistances were 450, look at 450 here and look at the first value. It was not 45, it was 450. It was not 38, it was 380, 490, 430. Actually, you're multiplying each value by 10. What if you multiply each value by 10? Could you use the results of the previous parts for this to find the standard deviation and variance of this data?
Yes.
What will be the standard deviation of this one? 10 multiplied by the old standard deviation, and variance will be 100 multiplied, but not 20 multiplied by 100 multiplied by. This is one of the common mistakes I see. A constant square is not 2 times the constant. In the heat of the moment in exam, sometimes you do that. So it will be not 2 times 10. It will be 10 to the power 2. And we are done. Let me write it here. For part B, the standard deviation of x plus minus 35 will be standard deviation of x. This variance of x minus 35 will be the variance of simply x. But for part C, the standard deviation of x multiplied by 10 will be s times 10, and standard variance of x multiplied by 10, that will be 100 times the variance of x. And we are done. Any questions? Yes. Which one? Here? Here? When will the median of a sample be equal to the mean? 1, 2, 3, 4, 5. Compute the median. 3. Compute the mean. Also 3. 4. 1, 2, 2, 3, 3, 3, 4, 4, 5. This is a much better example where I deliberately gave you a symmetric data. If you draw the histogram of this one, it will be like this. For 1, there is only one observation. For 2, there are 2 observations. For 3, there are 3 observations. For 4, there are 2 observations. For 5, there is only one observation again. Yes? Now, what is the mean? Mean is 3. What is the mod? Mod is 3. What is left? Median? Median is 3 for this kind of data. Mean and median will work for bimodal also. Yes, that's true. For this here. If you find the mean, that will be the red line. Median, the red line. Mod will not be the red line.
So the money we got.
If we got, again, I did not get your question. If your data is odd or even, it doesn't matter. It doesn't matter. If you do not have any question from today's class, you are free to go. If you have any questions, feel free to ask me the questions. Next class, I will start chapter 2.
This is the standard deviation. What about this?
I have it has been
I
more
use
than-
this and
more
the
than-
same as the sample.
more than 15 years I used a calculator.
Just remind about the.
Oh, wait. Let me